Thank you very much, John, and thanks everybody for coming to this special webinar. As John said in the introduction, I'd like to start off with talking about how certain SCM best practices can really help you with continuous integration, and how ultimately that can lead to improving the quality of your software. So we're going to go through a couple of best practices. We'll start off with looking at change requests and change packages as a good practice. We'll take a look at the ability to use and create reusable components. We'll talk about one of the key practices in continuous integration, which is frequent merging and integration. And finally, we'll talk about how to leverage and really measure the process so that you know how and in what direction to improve it. So let's start right off with change requests and change packages. A lot of different SCM vendors have this concept in their product, not all of them, of course. So AccuRev, for example, has the concept of change packages, but other vendors have change sets or change requests. The key similarity between all of the vendor products in this area is that you have the ability to create a logical as opposed to a physical grouping of code changes. So, for example, someone files a defect, and 3 files need to change in order to fix that defect. It's much more efficient and much easier in your process to work with a logical grouping of those 3 files that can, for example, be moved to other code lines or reverted if an issue arises and you find that there's a problem with that particular change package, as opposed to having to always deal with the 3 files individually. So just grouping things into change packages is a very easy way to make sure that your developers and your process managers are able to understand changes at a slightly higher level rather than always having to go down to the code level. The key thing that this enables as far as the process is concerned is the ability to tightly couple change requests with the actual coding activities. By doing this sort of grouping, you're making an assertion that changes to files A, B, and C represent a fix for issue 1, 2, 3. That's important information. That helps you at release time really understand the nature of what have you actually done in a particular release. One of the features that's key here, and that actually comes in very handy in continuous integration, is the ability to perform atomic operations. I mentioned some of the operations, for example, again in AccuRev, you're able to revert a change package, you're able to move it to another stream of development. The ability to operate atomically on the change package, again, fixes some of the most common problems that people have. Somebody promotes a file to a particular code line and they find out that just that one file was not sufficient to solve a problem, and what do you have? You have a broken build as a result of this impartial promote. So it's very, very useful to be able to do atomic operations on your change packages. As with most of the remedies and practices that we'll talk about today, this isn't going to magically improve the quality of your software. There's really no silver bullet or panacea for any of this, but it does help you to establish a measurable, repeatable process where you've grouped all of your changes together logically and you can manage them logically, and that ultimately does impact quality. Let's talk about reusable components. For those of you who've been in the industry for a while, this was certainly all the rage in the early to mid-90s when object-oriented programming came out. And objects, they were just going to solve all the problems of the world. World hunger, world peace, and C++ were really going to do everything. Well, almost everything. But the thing that did come out of that movement, and one of the reasons why you see so many object-oriented languages flourishing today, Java, C++, certainly example, and there are other languages that are up and coming. Ruby is a great example. The key is that architecture is important. And when you're able to architect your code in such a way that you have components and you can identify components for reuse, you have the ability to, for example, independently test those components. So we're starting to look at components as a way not just of isolating your code and doing some division of labor in your development organization. It's really a way to make sure that particular portions of your code that are shared have the ability to be fully and independently tested. The level of testing varies from development shop to development shop. Some shops that we've seen really don't do a lot of unit testing. Everything is system testing. Others will unit test, or white box and black box test every single line, every possible interface of every component. So somewhere in that spectrum is what's appropriate for your shop. One of the keys here is that it really helps you to reduce expensive rework. If you have a component on the shelf that's been used in several projects in the past and a need arises in a new project for something similar, this really helps to reduce rework. Remember, quality isn't only about what comes out of the door. It's how efficiently you're able to operate your development organization. So the ability to reduce rework is important as well. All right, let's move on to something that's really going to get us into continuous integration, merging and integrating frequently. One of the key features of modern SCM systems is that you really have to have the ability of doing very easy merging and what I like to call just-in-time branching, or branching whenever you need to. If you look at some of the legacy SCM system, ones that are really file and traditional branch based, a lot of the best practices around some of those products amount to what I call fear of branching. Meaning you'll actually see in the documentation, don't branch unless you have to. You really don't need to branch. We don't recommend branching. Well, this is a very odd statement, because if you think about the utility of branching, branching really allows you to isolate different code lines from one another. AccuRev streams are a different example. It's really designed as a replacement for branching, so that you can branch as often as you need. You just create a stream, and the next thing you know, you have a new code line that has a known established relationship to its parent code line. So the ability to do that is very critical. Frequent merging is another thing that is made easier by some of the more modern SCM system. And it might look like an odd statement initially that I say that frequent merging can reduce regressions. But ultimately, if you are constantly taking the work that individual developers and individual teams do, and you're merging that into some sort of integration code line, and you're testing that integration code line, then all of a sudden you've established a process that is going to identify defects earlier. To take a specific example, let's say you have two teams, a local team and an offshore team, and they're both working on the same project, and they're both promoting code up into a particular code line that's used for perhaps the nightly build. If you run a full set of regression tests on that nightly build and bugs come out, tests fail, then you know that you can stop